Alright, so we've seen how to rationalize an expression that has one root in the denominator. Now here's the advanced class. Sometimes there are two roots in the denominator and they're in the form of a binomial like this. Well, how do we get rid of both of those? How do you knock out two roots at once? Remember conjugates? Did you wonder why we were showing you conjugates? This would be why. If you have a denominator like root 5 minus root 3, its conjugate is root 5 plus root 3. You multiply by that. And you do the same thing upstairs. Now, we have to FOIL the denominator, and you're thinking, oh man, this is going to be a complete hairball. But, do you remember what conjugates did when we multiplied them out? The middle terms canceled, the first and last terms produced perfect squares. This denominator is going to clean up neat as a pin. It's going to be beautiful. The numerator will become a bit of a mess, but that's the price you pay for getting your denominator rationalized. Watch what happens here. You get 2 root 5. Then you get 2 root 3. And in the denominator, I'm not going to shortcut anything. I'll FOIL this all out so you can see what happens. Root 5 times root 5 makes root 25. Outside, root 5 times root 3 makes positive root 15. Inside, minus root 3 times root 5 makes negative root 15. And last, minus root 3 times root 3 makes negative root 9. So now when we clean that up, the numerator isn't getting any better. This is what it's going to look like. Unless we get really lucky with what happens in the denominator. Root 25 is 5. The root 15s cancel, and they always will. And then we get minus root 9, which is 3. Oh, it does clean up. Look at this. 2 root 5 plus 2 root 3, and it's divided by 2. Well, we can do that. 2 root 5 divided by 2 is simply root 5, plus 2 root 3 divided by 2 makes simply root 3. We were lucky that this happened. It was entirely possible that we'd get like 2 root 5 plus 2 root 3 over 7 or something, and it wouldn't have divided out so nice. But if you use the conjugate, I do guarantee you will get a single nice rational number in the denominator. And that's what we wanted. The numerator will probably get a little bit worse, but that's considered to be worth it. In B, root 6 plus root 2, our conjugate is root 6 minus 2. You notice that's the same as the numerator. That's just a coincidence. They're trying to weird us out. But it's not going to work. So when we FOIL the numerator, we get root 6 times root 6. Outside, we get minus 2 root 6. Inside, we get another minus 2 root 6. I'm trying to keep this compact because they didn't give us a lot of room here. Minus 2 times minus 2 is plus 4. In the denominator, all the beautiful stuff happens. We get 6 minus 4, right? Because the middle terms cancel out. You do FOIL, but the F and the L are the only steps worth doing because the other two cancel out. And so you get 6 plus 4 is 10 minus 4 root 6 over 6 minus 4 is 2. Again, we luck out and these are divisible. So we can do 10 divided by 2 and minus 4 root 6 divided by 2. And that will be our finished answer. C, out come the variables. The denominator is 1 minus root x. Its conjugate is 1 plus root x. Whoops, x. And we must put the exact same thing up top. So when we multiply this out, upstairs, nothing easier, 1 plus root x. Downstairs, we get 1 times 1. We get an outside and inside term which cancel, so who cares? And in the end, we get minus root x times root x, which makes minus x. Not the most beautiful expression ever, but the denominator is rational. That's what they wanted from us.